Wait, how do you know she took a tumble?
Well, I'm talking. Somebody asked her, what happened to Miss Bradley?
Not a tumble right before Christmas. That's very sad. All right, y'all, we're starting on the one that we skipped last time. So I don't know if you remember, but we didn't do 23 just because it kind of didn't really go with last time's lesson, and it goes a little bit better with today's. Okay. All right, and then just to give you kind of a heads up, about 20 minutes before the end of class, I'm going to come look at your review and give you a grade for what's done right now so that I can put it into the grade book. Then on your, let's say you get like a 50 because you've not been doing it. Then on your exam day, if you want to return it in for a better grade on Monday, that's totally fine. But just so that I don't not have a grade in for you at all, I'm going to take like a little progress check today. Okay? Yes. No, it will not be late because as long as you do it before your exam, that's kind of the deadline. Okay. All right. So number 23, it says you have an F and a G. Okay. So we'll do this one. So we have our F here. We have our G here. And then it says, what is the set of real numbers where G of F is defined? So you should remember that if I want G of F, that means that I'm going to plug the F formula into the G formula. So my G formula is 1 over X. Then my G of F is going to be 1 over, and then I'm going to plug this formula into that X spot, which means that it's going to end up down here on the bottom. And then from there, you should know how to find what your X's can't be. It's going to be any vertical asymptotes or holes. Remember, that comes from you factoring the bottom. So how could I factor the bottom of this guy? What could we take out? 2 and X. Very good. So I'm going to have a 2X on the outside. That's going to leave me with an X minus 5. Which means that I have vertical asymptotes at what numbers? If I have an X minus 5 in parentheses, then where's my asymptote at? It's a minus 5 here. It would be positive 5. And then do you remember for an X on the outside what the solution is? 0. Very good. Now, one thing that is a little bit tricky about this is they're asking you what the real numbers are going to be defined at. This is where it's undefined. Remember that for vertical asymptotes, those are the X's your graph can't touch. So if they want to know where the graph is defined, you would basically say everywhere else, but just not these two numbers. So we would put it is defined from negative infinity to 0, and then again from 0 to 5. And then again from 5 to infinity. So basically you're saying everywhere except don't touch 0, don't touch 5, everything else on the number line. Because vertical asymptotes are the X's that your graph is not defined at, you would basically list everywhere. Okay? All right, go ahead and turn the page, please. All right, so we are going to do number 27. You'll turn the page to here. Okay, and then it looks like your circle got a little messed up. It should be on the graph right here. Okay, so it says label the end behavior on the ends of the graph. So if I want to be on this end, what is X going to? Negative infinity. And then is my graph going up to infinity, down to negative infinity, or is it approaching the x-axis? And the x-axis means that it's getting closer to 0. So remember that it could be flattening out towards a number, or it could just be going up or down. Okay, same thing on the other side. As x goes to infinity, that puts me on the right end of the graph. Then you would say your f of x is going to. Okay, because your graph isn't just going up or going down, it's curving off specifically towards the x-axis, which is 0. Okay, so I'm going to put a little check here. Then it says, fill in the blanks. F of x has a removable discontinuity at blank and vertical asymptotes at blank. Okay, a removable discontinuity and a hole are the same thing. Where is the hole on the graph? What x value? -4. And then vertical asymptotes, where do those happen? So this one, if this is -4, this would be -5. And then this one would be where? At 1, very good. Now remember, those are the x's that your graph can't touch. You can't touch the asymptotes, and then you skip over the hole. So if it's asking you for the domain, there are 2 ways that you could write it. You could say all real numbers except x can't equal -4, -5, or 1. Or you could list it out in number lines like we did on that other question we just did. So you would say from -infinity till -5. Then from -5 to -4. Then from -4 to 1. And then from 1 to infinity. So basically, you're just listing out, if I can't touch -5, I have to stop. Can't touch -4, we'll have to have another little break, and then you can't touch 1. Okay? Questions on that? All right, go ahead and turn the page one more time. Okay, let's do number 30. Okay, first question, you're asked to find the horizontal asymptotes. Remember, these are your Bobo, Bot, and Betsy rules. So looking at the equation for 30, Bobo, Bot, and Betsy. Okay, what type is 30? Bottom means the bigger power is on the top. So if it's an x squared versus another x squared, what would that be? Betsy, very good. So if both powers are equal, you divide the numbers in the front, which means that in this case, it would be 2x squared compared to 1x squared. What is 2 divided by 1? 2. Now, good news for y'all is that you will not have to graph these on your semester exam. You just have to be able to say what the features are. Okay, holes. Remember, to find every other feature, you have to be able to factor. So let's factor our equation out of the top. What could I take out of both? What GCF? 2. And when I take a GCF of 2 out, what is that going to leave me with? My 2x squared, now it'll be just a what? X squared, and then my 18 will now be a 9. Okay, now that's not all the way done. This is now a perfect square. What is the square root of x squared? And then the square root of 9 would be plus or minus 3. So it's going to be 2x plus 3, x minus 3. Okay, that's the top that we took the 2 out, then we did perfect squares. Okay, for the bottom, you're going to ABC it because it's got 3 parts. So it's A, B, C. For my little chart here, I want 1 times 15 is 15. That's my AC. And then I need numbers that are going to add to B, my basement number of 8. What numbers will times to 15? 1 times 15 or 5 and. And then out of those options, which one's going to add to 8? The 5 and the 3. Now remember, if your A is a 1, you're done, which it is. So it's going to be x plus 5 and x plus 3. Okay, then from there, remember, poles or removable discontinuities are the ones that cross out. What's gonna cross out from your equation? +3, and if x +3 crosses out, where will the hole be at? -3. Vertical asymptotes, are they the x's left on top or on bottom? Okay, bottom, very good. So the x left on bottom for this one is a +5, so I know it's gonna be at -5. And then zeros or any x's left on top, I have an x -3, which means it's gonna be at +3. Okay. And I'll put these other ones. Okay, but last thing I'll add with this before we go on is remember, you get to use Desmos and a calculator. So most of these features, if you graph it, you could just see wherever you have that missing x, you know it's a vertical asymptote. X-intercepts where it crosses the x-axis, you can find those things there as well. All right, next one, we're gonna do 31. We'll do the second or the first question. Okay, you're asked to find the slant or oblique asymptote. Remember that oblique asymptotes occur when it's a boson, and the top is exactly 1 power bigger than the bottom. Okay, so if you are asked to find which equation has a slant asymptote, you need the top to be 1 bigger than the bottom. So for example, here it's an x squared versus a regular x, that's a 1 power difference. Okay, the way that you find it is long division, top divided by bottom. So we'll do x squared plus 5x minus 6, and then 2x plus. Okay, for this one's a little bit tricky, but we have done a question like this before. I need my 2x to turn into an x squared. What would I have to multiply for my 2x to turn into a 1x squared? Or I'm gonna put a half, but 0.5 is the same. So 2 times a half is gonna make this a 1. And then what am I also gonna need for my x to go to an x squared? Another x squared. Then I'm gonna do 1/2 x times 2x. That's a 1x squared. And then 1/2 x times 2, that's a 1x. But before you combine the rows, what do we need to do to the signs? Do you remember? Change them. So this is going to go minus, minus. X squared minus x squared is going to cross out. 5 minus 1 is going to give me a 4x, carry down minus 6. And then I'm going to repeat the process. What would I need to times my 2x by to perfectly match a 4x? 2x times plus 2. 2 times 2x is 4x. 2 times 2 is 4. And then remember, we're changing the signs. Now, quick question. Do I need to keep finishing this out? No. No, I already have the answers, that top part. Okay, so obviously you could keep going. Okay, but this is the answer right here. So I'm going to put do not need the remainder. Okay, your answer is y equals 1/2 x plus 2. It's that part on the top. Okay. Yes. Correct. All right. Last page, you have some matching. Do y'all want me to help you with the graphs or the equations? We can do one or the other. Maybe equations is harder? Want to do graphs? Okay, let's do the graphs. All right, so let's start with, I need a graph. Look at, you have 5 choices. I need a graph that has a vertical asymptote and an oblique asymptote. That means one of them needs to be vertical one of them needs to be a slant. So look at your options. Which one has a vertical and a slant? B is correct. Here's your vertical. Here's your slant. So it has to be option B. Okay, next one. I want a horizontal asymptote at 3. Look at your graphs. Which one flattens out to a height of 3? C is correct. That's your horizontal asymptote at 3. Next one, I need 2 vertical asymptotes and a horizontal asymptote. Okay, E is correct. 2 verticals and a horizontal. That would be E. Next one, I'm looking for a graph that is even because it has symmetry. Both ends have to be going the same way. A. Okay, notice that even both of your ends are pointing down. Okay, and then last one, we know it has to be D, but a vertical and a horizontal. Here's my vertical. Here's my horizontal. So that would have to be. Okay. All right. Last question we have to do is the one that we skipped. So if you'll go back to this guy right here, number 25. Okay, and then if you have your calculator, that would be great because you'll need it for this. So I'm gonna just go ahead and start typing it into y equals. We're gonna look at the graph here in a second. Okay, so when you graph it, all you're gonna see is a little sliver of the graph like this. Okay, actually, let's answer the preliminary questions before we do the solving. So what is the degree or the highest power that you see in this equation? What's the highest power? It's a 4th degree. Okay, and then the leading coefficient would be the number in front of the term that has the highest power. So if x4 is the highest power, what's the coefficient in front of that? A 1 is correct, because it'd be like the number that comes in front of the x, it would be a 1. Okay, then it says, what are the end behaviors? Okay, from our graph, we can see that both ends are going to point up. So both ends up. Now, you also could, if you like Desmos better, you'll get to use that on your exam as well. Okay, but for this question, the calculator's good enough. Okay, then this is where it's a little bit tricky, but there's a question just like this on your exam. It asks you to solve the polynomial. Now, we have a lot of options to solve. We can do perfect squares. We can do greatest common factor, ABC chart, and then the last one is grouping. For grouping, how many terms are you allowed to have to divide them into groups? 4. How many does this one have? It has 5. It has too many. So what you're going to do is, on your graph, do you see where it hits the x-axis? What number does it hit the x-axis at? 5, and it's a whole number on your test too. I think it's maybe like 1 or 2 or 3. Okay, but if it crosses at 5, then we're going to pull 5 out of the equation. So we're going to do that using synthetic division. So we know that our graph crosses at 1, 2, 3, 4, 5. I'm just going to draw a picture. So I know that x equals 5 is an answer. But because my graph has too many terms for me to do grouping, I'm going to pull the 5 out so that I can do grouping on what's left. So put a 5 in the box. And then I'm going to do a 1x4, a minus 10x3, a 41, minus 160, and a 400. Now remember, when you do synthetic division, you're not putting the x's, you're just putting the numbers. First number comes straight down. What is it? A 1. Then what do I do with the 1? Multiply it by what's in the box. 1 times 5 is 5. Then I combine that column. What's negative 10 and 5 together? Negative 5 is correct. Negative 5 times 5, what do we get? Negative 25. Then we'll do 41 minus 25. Gives me 16. Then what do I do with the 16? 16 times 5 gives me 80. Then I'm going to combine these two together. What's negative 160 plus 80? Negative 80, very good. And then negative 80 times 5 is negative 400, which gives me a remainder of 0. Now, here's why that's good for us. That I know it was supposed to be a remainder of 0 because I already knew that was an answer because I looked at the graph. Remember that if my answer started as an x4, then what is this going to start at? An x3. And that's going to allow me to do factor by group. So it's a 1x3 minus a 5x2 plus a 16x minus 80. And now we can group what's left. All right, so take a look at your first two factors. I have an x3 and a minus 5x2. What can we take out of both? X squared. When I take the x squared out, what's going to be left over from that first group? X minus 5. Okay, out of my second two, what can I take out of both of these? Pretty sure it's a 16. 16x, if I divide the 16 out, now it's just an x. What about 80 divided by 16? We get minus 5. Now remember, when you do grouping, your parentheses are supposed to match, do they? Yes. Which means that x minus 5 is my first factor, and x squared plus 16 is my second factor. Okay, so remember, as long as these match, which they do, that's factor number 1. And then whatever the GCFs were, that makes up factor number 2. For x minus 5, what's the next answer that I get? It's a minus 5 in parentheses. What's the answer going to be? Positive 5. Now, quick question. How many times did I get 5 as an answer? Twice. Does it make sense then why the graph bounces? You remember we called that a double root when we covered that? So 5 came out to be an answer twice, but that makes sense because I see that there's a bounce in the graph at that spot. Okay, the remaining term right here, set it equal to 0 for me. So if I let x squared plus 16 equal 0, what would I do with the plus 16 to solve? Minus the 16 across. That gives me x squared equals negative 16. And then from there, how do we get rid of the squared? Take the square root. And then what is the square root of 16? 4. So it's going to be plus or minus 4i. And do you remember that the I comes in because you're square rooting in negative? Those answers are imaginary. So if you look at your graph, do you see that it never crossed the x-axis again? That's because your other two answers are imaginary. That means you're not going to see them on the graph. Okay? All right. So you have the rest of the class to work. Okay, try to fill in the gaps on the ones that we skipped. And then around 10:10, I'll come around and just give a grade for what you have done so far. And then your final grade will be what you turn in on your exam day.